Welcome to Brain Vision.
We know that torque for a magnetic coil is given by the cross product of magnetic moment times the magnetic field. And the potential energy in this system is given by the dot product negative of the dot product times the magnetic field. So this is equal to negative of the magnitudes of both the vector times cos phi, where phi is the angle between them. And in both the cases, the magnetic moment mu is given by n times, where n is the number of turns times the current times area. So this means that tau will then be equal to, so we can write tau separately. So yeah, this means tau will then be equal to n times I times A. So let's say the direction. So the direction is given by the cross product of both these vectors. So for simplicity, let's just write the expression that we get from here. So mu is basically equal to mu times b times sine theta. That's the magnitude of, torque. The magnitude of torque is equal to mu times b times sine theta. And for the first case, phi is equal to 90 degree. That means tau is equal to, so mu is now NIA, so n times A, b sine phi, which is equal to n times A times b, because sine phi is basically 1 here. And the direction is given by k cap, which is the perpendicular to area, times the direction of magnetic field, and this is equal to negative I. Similarly, for potential energy, we have mu b cos phi from this equation, and this is equal to 0 because phi is 90 degree. For the second part, phi is equal to 0. So this means that torque is going to be 0 from this equation because phi is 0, and potential energy will be negative of mu b because cos phi is going to be 1, and this will then be equal to negative of NIA times b. For part C, phi is 90 degree, so tau is going to be same as here, except here the direction will be negative k cap times j cap, because here the direction of mu is along positive z axis, here this is along negative z axis, and this is equal to I cap or positive x direction, and potential energy is going to be 0 because cos phi is 0. Now for the last part, let's write it over here. So for the last part, phi is 180 degree. That means this is going to be equal to 0 because sine of 180 is 0. And the potential energy is going to be mu b cos of 180 degree. So this is basically minus 1. This gives the potential energy U to be equal to n times A. So minus minus becomes plus, and mu is NIA times the magnetic field. So you can see now that comparing all these parts, when torque is maximum, the potential energy U is coming to be minimum. And when the magnitude of the potential energy is maximum, you're getting the torque to be 0.